So in this video, I wanted to help out with, this is section 1.2 homework question 9. So the question is asking about finding open intervals over which this function, whose graph is here, it looks like some kind of piecewise function, over which this function is increasing, decreasing, and when is it constant. Now, looking at the graph, determining where it's increasing and decreasing, that part's not so difficult. But giving the answer the way we need to state it, that's the trickier part here. So the key to when you're listing these open intervals over which a function is increasing or decreasing, just in general when you see this phrase over which, our answer needs to be in terms of x values. So the key here is when we list our intervals, these need to be intervals of x values. Okay, so we'll have to keep that in mind throughout this problem. So our answer is going to be pinned to the x-axis. Don't look at the y values when you're giving your final answer here. Only look at the x's. That's key. Okay, now when you're determining, looking at the graph here, and let me give you some of the key features. So this graph has, it starts out on the left, it's a horizontal line until it reaches this point at -2, 2, right here. That's the coordinates at this corner right here. And then it's a line with a negative slope going down to this point at 3, -7. And then at that point, it's going to change tracks into this line with positive slope going up through the x-axis at 6 and then increasing upward and to the right, to infinity. So there's your graph. You might want to jot that down on a piece of paper. Like pause the video and do that. Okay, but so reading across this graph, always when you're determining intervals where it's increasing, decreasing, constant, make sure you read the graph left to right. So if we start on the left-hand side and just start tracing the graph, for this first section, the graph is flat. So on this interval here, the graph is constant. Let's see if I can fit that. Now, like I said, when we give our answer, it needs to be in terms of x values. So I'm going to shade the x-axis. So the graph is constant for all of these x's until x reaches -2. This is the interval over which the graph is constant. And I'll come back and write that interval over here in my answers in just a minute. But right now I just want to kind of analyze the graph. Okay, so on this next section, when you trace it left to right, the graph is decreasing. So it's decreasing over this whole section here, which means it's decreasing. So this whole section of the graph, the key thing is, okay, so what x values are we talking about? So we're talking about from the time when x is -2, right here, until we get to 3, right? 3 is the x value where it stops decreasing. So from -2 to 3. This is the section of the graph where it's decreasing. And I think I will go ahead and give the answer over here. So it's decreasing on the interval from -2 to 3. So this is the answer for part B, the way I've set it up here. If you're wondering why is it open, the round parentheses and not the square bracket, the hard bracket, the reason is, so in general, for increasing, decreasing, constant, just use parentheses everywhere. Because at the x value where it actually turns around, so at 3, let's say, we can't really say that it's decreasing or increasing. It's changing from one to the other at 3. But if you're at an x value just a little bit less than 3, so like 2.999, the graph is decreasing. If you're at 3.00001, the graph is increasing. So that's why we use the round parentheses here. If you're a little bit less than 3, then you're on the decreasing section of the graph. And then if you're a little bit bigger than 3, let's go ahead and talk about it. So this section, when you trace it left to right, the graph is going up. And so for all the x values corresponding to this section of the graph, so from right here where x is 3 out to infinity, the graph is increasing on this whole section of the graph. So we would put that it's increasing on the interval from 3 to infinity. Notice we're not listing y values at all. We don't care when you're listing where is it increasing, where is it decreasing. we don't care if it's increasing from -7, or y is starting down here at -7, or if y was starting at 28 and then increasing from there. It doesn't matter. It's increasing either way. So y value doesn't matter. But we're saying, where does it increase? So if your answer is supposed to be where does it increase, you need to give your input values, which are x values. So it's increasing on the interval from 3 to infinity, because that's the x values that correspond to this section of the graph. It's decreasing on the interval from -2 to 3, which I put here because that's the x values that correspond to this section of the graph. And then it's constant on this section of the graph over here. So the x values that correspond to this section would be, got too many markers in my hand again. Can't get this lid off. Okay, -infinity to -2. It's constant in this section of the graph here. So it's constant for these x values, which is -2 to infinity. Again, we're not looking at the y values at all. And so these would be your answers for where is it increasing, where is it decreasing, where is it constant.